All right, so let's kick it off. So I'm Ksenia Peguero. I am from Siberia originally, and been working in the security field for over 8 years now with a company used to be called Cigital, acquired by Synopsys, so now with Synopsys. I used to be doing consulting for a good 6-7 years, and now I'm focusing on research now that we officially have an R&D department. It's awesome. I absolutely love it. And I concentrate on research in JavaScript and web technologies. I'm also doing my PhD. It's going to take me forever at George Washington University, and I tweet on security stuff. And I have a little girl. She's amazing. She's going to turn 1-year-old next week. And in my free time, when I have free time, which is almost never, I do ballroom dancing. But also one thing, because I am from Siberia, I grew up where we have like 6 months of snow. So what do you do when you have 6 months of snow? Guess what kind of sport you play when you have 6 months of snow? This is incredible. Like last night was amazing. My dad played hockey professionally in Russia. So I grew up in a hockey field. So last night was just, All right, so now we're going to talk about JavaScript. So today I'll talk about JavaScript kind of field, a little bit in general, covering, in terms of security, of course. We'll talk about common JavaScript vulnerabilities. And then we will look at frameworks, because everything is frameworks in the JavaScript world. And I'll have some demos and some specific examples in React framework. The securities, the security problems, the mistakes that developers make, and how do we fix them, which is more important. And I do have the demos, so praying to the demo gods. So who here has written JavaScript? The light is just right. Awesome. Who has written in React? All right. Who knows what is cross-site scripting? Woohoo! Awesome. That's real good. So I love JavaScript. And if you have written JavaScript, you probably have a love-hate relationship. And that's like one of my favorite quotes from Twitter is, JavaScript makes me say, screw all this, but I do not always know what this means in this context. All right, geeky jokes. So JavaScript, we're going to talk about client-side and server-side, right? It's because now we can have JavaScript on the server-side. So if we talk about client-side JavaScript, again, another amazing quote where there are more JavaScript frameworks than there are applications that are using them. And notice that this quote is from 2012. Guess what? No, there are even more frameworks. The latest, what's the name of that blog? It's JavaScript Report. Somewhere in February or January, they came out with a list of popular JavaScript frameworks. And they listed over 50 of them that are being used. I mean, some of them have very specific use, right? So you're not going to know all of them. But like there are over 50 JavaScript frameworks. How do we live in this world? Like, how do we work? How do we keep up to date? That's the biggest thing. And yeah, this is how we wrote code in 2004, and this is what's happening today. And again, this is a comic from 2014. 2 months later, is it still up to date? I'm spending 2 days in Richmond. When I come back to work on Monday, maybe React is not going to be a thing anymore. It's developing so fast. It's just incredible. So frameworks, the good, the bad, and the ugly, right? All right, so they're great because if you know the framework, the development is much faster. If you wrote React, how long does it take you to start your React app? It's like one line of code, right? I mean, one command and pops up your framework, well, the kind of the structs for the application. If you're familiar with the idioms, it's pretty easy. And because you're using so much open source code that's already, so much code that's already in the framework, if the security features are built into it, then you just have them for free by default. This is awesome. The bad, so if you don't know the framework, it's a pretty high learning curve, pretty steep, right? It takes a while, especially if you are in the security field and you need to do code reviews, or you're not a developer, and you have to learn those new frameworks, every couple of months. That's hard. It's not easy. Okay, if the security features are built in, awesome. If there are bugs in the framework, not so great, right? The other thing is with the frameworks, oftentimes they are very targeted to a specific task. So if you compare them to Java Spring framework or Struts framework in Java, those frameworks were more over-encompassing. Also, they are server-side frameworks. But even if you compare them to Express or Sales.js, the server-side JavaScript frameworks, the older frameworks, they kind of cover all the tasks and a lot of different features and things a developer needs, where in the JavaScript, in the kind of more fast-paced frameworks, they focus usually on specific tasks. So if you need to do something else that's not built into the framework, you're going to use third-party plugins. And the quality of the code, not always great. A great example is Angular. Angular by itself is pretty secure. It has a lot of good things built into it. And when we did the analysis, most of the bugs, most of the vulnerabilities we find are actually in Angular plugins because the quality of code is not as great. Fragmented knowledge, poor documentation. This is not news. This is not just the JavaScript frameworks. But the reality is we cannot live without them, right? Who's going to write vanilla JavaScript? Nobody. So we have to somehow deal with it. So if we look at the client-side JavaScript security problems, what are the common issues that we usually find? Cross-site scripting, obviously. Again, since we talk about client-side, those are going to be most likely DOM cross-site scripting, not the traditional, going to the server and doing validation on the server side. A lot of languages frameworks have expression language, Angular has expression language, Vue has their own expression language. So now we have the expression language injections or expression injections, which can later lead to cross-site scripting. So it's another new bug. Clickjacking. Anybody familiar with clickjacking? Yeah. So usually for clickjacking, you need to have JavaScript executing in the application. Well, there is SVG clickjacking now. For example, again, Angular was vulnerable to that, where you can change the UI of the application with just SVG. You don't have to actually execute the script, but it looks like you put another button on top of the button where the user is supposed to click, and you grab their clicks and do some malicious stuff. DOM clobbering, that's not new. It's been around for a long time. But with the JavaScript frameworks, with the heavier logic on the client side, that's happening more often. And what DOM clobbering is that if you can inject HTML, suppose you cannot inject JavaScript, right? You can inject HTML, and you inject an element with an ID that's already used in the page. So now you have two elements with the same ID. Guess what? Some browsers are going to treat that not as two different elements, but as an array of elements. So the properties are going to be different, and the code execution is going to be different. And you can do some interesting stuff with that as an attacker. Client-side trust issues. Again, nothing new here, but because we have so much logic on the client side, that's coming up more and more often. And it also kind of leads to information leakage. So for example, if we look at Meteor, another JavaScript full stack framework, by default, when you start a Meteor app, it uses the pub/sub methodology to query data, get the data to the client side. By default, it's just going to return all the data from your database, right? If you don't do authorizations and checks, so you may be leaking a lot of information on your web page. And CSRF, partially because it's the client-side part of the CSRF when you have to submit the token via cookie or via the header. Some frameworks will kind of do this job for you, like Angular, for example, will grab the header from the cookie and put it in the token from the cookie and put it in the header, and you just need to validate on the server side, right? But other frameworks don't provide that, so you have to write that manually. So that's kind of still an issue. But then, as I said, we can run JavaScript on the server side. So what about the server-side vulnerabilities? Are they JavaScript specific? No. Same thing as we find in Java, PHP, or whatnot. So same injection issues, same, again, CSRF, the server-side part of the cross-site request forgery, code execution, authentication, authorization. Kind of the newer thing is deserialization. Now it's in the OWASP. So in JavaScript, we have the magic function Eval, which is whenever you see Eval, you should think evil, right? Because you don't evaluate untrusted code. But I'll show you example with JavaScript. Like sometimes there's no other way around. It's really hard to fix it because you have to fix the architecture. So we're not going to talk about these issues in this presentation because we're talking about the client-side JavaScript, right? So if we look at OWASP and align OWASP with the JavaScript, how does it relate to the client-side JavaScript applications? So injections, as I said, expression injection. So that's a new type, well, sort of new type, right? So yes, we cannot do a SQL injection, a command injection, LDAP injection, but we can do an expression injection. So that's something to look after. Broken authentication, same as the authorization. Well, if you do authentication authorization on the client side, guess what, right? Can be bypassed. So that's definitely something to look at. Sensitive data exposure, we talked about that, sending all your database fields or, I guess, attributes if you're using the NoSQL DB, not filtering them to only what the user should see. XML external entities, not really in client-side code, right? Because we usually don't, well, one, in JavaScript applications, we usually don't parse XML. It's usually JSON. But two is because it's a client-side, we kind of don't care because there is nothing we can pull, on the client side. Like there are no entities from the server that we can pull on the client side. Broken access control, I mentioned again, if you trust the client and your authorization is on the client side, can be bypassed. Security misconfiguration, this is big because we're talking about the frameworks. So especially if they come with some security features and you misconfigure them, or like either they come with non-secure defaults and you don't change the defaults, or they do come with secure defaults and then you change them to something unsecure, so that configuration becomes a bigger part. Insecure deserialization, cross-site scripting, of course. Deserialization more often happens on the server side because on the client side, if you send serialized data, usually the browser can process it in most of the use cases. You don't need to worry about the deserialization on the client side, but if you do, then with the eval function, you can get yourself into trouble. And using components with known vulnerabilities, I mentioned the vulnerable third-party plugins that you need to be very aware of. And insufficient logging and monitoring, usually you don't do logging on the client side, but if you are using some sort of like Google APIs, collecting statistics, etc. So you may kind of cover yourself on this end with those third-party statistics aggregation services. Right? So what about the frameworks? What do they give us? What do they bring to the table? They do have, as I said, some security features. So for example, contextual encoding and template engines. Most JavaScript frameworks, Angular, React, Vue, they do automatic contextually based encoding, right? So if you are injecting into an HTML tag, they will do HTML escaping for you. If you inject into an attribute, they will do attribute escaping for you. Pretty good. CSRF protection, as I mentioned, for example, Angular has this feature, React doesn't. Type checking, again, if you're using Angular, whatever the latest version, 5, 6, right? You're using TypeScript, the strictly typed JavaScript, which is pretty good. Sandboxing, so again, some frameworks, so again, Angular, for example, had that concept of sandbox of whatever user script, functions are executed in the sandbox that prevents you running vanilla JavaScript and popping an alert or like calling to external services. And they always said this is not a security feature, and with every release, that was AngularJS, right? The first version, you were able, well, the attackers were able to break out of the sandbox where finally at version like 1.6, they said, all right, screw it, we're not gonna have the sandbox anymore, and the later versions of Angular don't have it. So, and sometimes frameworks can provide you a way to whitelist your resources, again, to prevent, attacker loading something from a malicious website into your client through an AJAX call. And then the insecurities, we mentioned the expression injection, the sandbox bypasses. Frameworks will have insecure APIs, and we'll see some examples that are, meant to be used very carefully, but if you're not careful, then you may open yourself to a cross-site scripting. And content security policy bypasses. There were cases where the application itself may not have a problem with content security policy, but because of the framework that you're using and the vulnerability in the framework, Angular had that, Mojo, I think, had that, and there was another one. The name is escaping me. But it's a JavaScript framework that had a content security bypass, basically content security policy bypass. Basically what happened was that you had a content security policy. Who's familiar with content security policy here? Oh, okay, a couple people. So it's a technology that allows you to tell the browser that you're only allowed to loading, well, the page is only allowed to loading resources from specific origins, right? So you say, I only trust scripts that are loaded from my, scripts.example.com, and I don't allow loading scripts from somewhere else. And the browser is the one who enforces this policy for every user. So with the framework, and usually the other feature that it will give you is that it will not allow running any inline JavaScript. And that's how most of the injections happen, right? So with the content security policy, you say, okay, no inline JavaScript. But because of the quirks of the framework, you can, for example, inject the code for, like in this framework, like some Angular Angular directives, right? Or some other framework directives that will not be technically JavaScript, so the browser is not going to block them with a policy. But then the framework will execute those directives, and they will be turned into something malicious. So there were some cases with that. All right, so today we're going to talk about React specifically and kind of look at some of the examples of React. Why are we talking about React, right? Well, that's the kind of the new hottest thing on the block. If we'll look at the statistics here from NPM, Angular, React versus Vue, I mean, React downloads are up there. Vue is actually catching up. So we'll see what's going to happen in like 6 months. Maybe Vue will be the newest, biggest, hottest thing. How did React come along? So it was introduced in 2013. And in 2013, 5 years ago, AngularJS was, the biggest framework. And what happened was that at that time, so that was still Angular 1, right, AngularJS. At that time, the Angular team was saying, okay, we're going to release Angular 2, and it's going to be a breaking change, and it's going to be this, amazing framework, all these great features. But the breaking change part, right, like developers don't like breaking changes. We don't want to rewrite the application from scratch. And it was basically a completely different framework. So one thing they said, okay, we got, there's going to be this new framework that you have to write your applications. But then they waited. They announced it in September of 2014, and they released Angular 2 in 2016, almost 2 years later after they announced it. So for 2 years, developers were in this limbo, right? I'm still writing Angular code, or I'm starting a new application. Should I write it in Angular? So Angular 2 is not available yet. I'm going to start it in Angular 1, but then they're going to finally release it, and I'll have to rewrite it. Like, I don't want to be in this situation. So React came along with these new features. The JSX, the templating engine, the templates were much easier to write than in Angular. The virtual DOM, we'll talk about it a little bit later, but one of the biggest thing was the one-way binding. So in Angular, there's two-way binding. You change the model, the view changes automatically. That's pretty standard. But it was two-way, so you change the view, so you changed something on the HTML, on the page, on the, the front end, and the model changes automatically. Sounds great, but it's really hard to maintain for big applications, for big, heavy pages. So React says, no, we're not going to do this. It's going to be one-way model to view, and that's it. And if you have to change it the other way around, to change the view, you have to send the request to the server, change the model, update the view. And it's only one-way change. So, and it was backed by Facebook, Google versus Facebook. So it was pretty well supported. So a lot of people switched to React in that time. I'm talking about JavaScript frameworks, and then I'm talking about React, which is technically is not a framework. Like if you look at their documentation, they say React is actually a UI library. And the reason why they say that is because, as I said, it's a very targeted solution for a very specific problem or use case. They didn't want to cover all the other things that the framework is supposed to cover. So for example, they don't have any state management, any routing, as I said, any CSRF protection. They don't worry about it. Like that's just the UI library, but it's used as a framework. Like when you ask a developer what is your application written in, they say, oh, it's in React, right? Kind of treat it the same way. And they also say, oh, we're not opinionated, right? You can use whatever router you want. You can use whatever state management you want, but really, most of the applications are using Redux. Like you kind of come up with these standard solution, standard blocks that everybody is using anyway. And it's also very opinionated about how you write the code because it's based on the functional programming. It's not a functional programming language because it's still JavaScript, but the ideas are like everything is a function. Every component is a function. So it's a slightly different way of writing the code. And has a bunch of plugins and very diverse ecosystem. So this is how a component in React looks like. It's a function, and then inside your return statement, so this is the JSX, right? Their template looking, the template language kind of that's built into the JavaScript, where you kind of stick some HTML-looking things inside your JavaScript and say, okay, this is component is a button and has an onClick method, and this is the class name. So think about it. When we were writing HTML in the 90s, we had HTML files, and then we had JavaScript inside the HTML files. And then we're saying, oh, this is not good, content security policy. We have to separate. HTML should be separate. JavaScript should be separate. Angular and all these frameworks, like, okay, it should be separate. And now it looks like we have HTML inside the JavaScript. It's like it's switched, and we're back in that same two-context world, sort of, in the files. So let's look at some of the vulnerabilities. So React cross-site scripting has output encoding built into it, all great. So if you are trying to output some malicious input, some untrusted data, and you put it in curly braces, automatically escaped, awesome. Because React doesn't change the inner HTML property of the element. But if you absolutely have to, and unfortunately it happens very often that you have to do that, there are functions called dangerously set inner HTML. I like how they call the function. In Angular, it used to be trust as HTML. Kind of, I just trust my framework, right? Whereas here it says, no, this is actually dangerous. I'm going to speed up because we're going to look at the demos. Then React doesn't have expression language. So no expression injection, awesome. But we generate components dynamically. So we can. Like we create components. So if we are generating a component dynamically, we may have a component injection. So let's look at that. When we create a component, we are providing 3 elements. So here is JSX on the left. And if we kind of transpile to JavaScript and just change it into just a function called react.createElement, we are sending 3 parameters. We're sending the type of the element. In this case, it's a header. We're sending the properties. So those are going to be the attributes. And we're sending the children. So in this case, let's a text node, and we say hello world. So we can inject into all these 3, potentially, all these 3 elements. One was the injection into the, first it was injection into the actual value that you're outputting, right, the children part. So if we look at this code, we're saying, OK, so this is attacker payload. We're submitting it in curly braces. It should be fine. We just said here, right, that whatever is in the curly braces is going to be output encoded. Well, it will if it is a string. But as you know, this vulnerability was discovered on the HackerOne website, which is pretty cool. If you are submitting not a string, but an object, a React object, which is a JSON object, and to be a React object, it just has to have an attribute that's called isReactElement equals true. And then you supply all the properties, and one of the properties will be the dangerously set HTML with your payload. React will actually interpret it, as the object and will not do any escaping. And there is your vulnerability. There's your cross-site scripting. So this was fixed pretty quickly. So not possible anymore. Good. But there are still two other avenues, right? So there is the title, the type of the attribute of the element that you're creating. So if we can inject into H1, all right, well, we can create a div element, a span element, some other element, but we cannot inject any attributes here. Can we execute any JavaScript? Not really. I mean, you create a JavaScript tag, but there is no script attached to it. So that's, not as interesting. Then we can inject into properties, which become attributes. So that's more interesting, because then that's where you will inject your dangerously set inner HTML, right? So that might still be an issue. And then if you can inject into the children, actually, before I get there, so talking about the injections into the attributes, right? Well, actually, the children was the example with the full element that we created here. So that was the third one. So the properties, there are other properties that are vulnerable. So for example, the href. Again, that's been around forever. It's a link, but we can inject the JavaScript header, and we can execute JavaScript in the href. In any JavaScript, doesn't matter which framework. React also obviously is vulnerable to that. And not just the JavaScript. You can also inject the data schema, and then which will be the whole content of the value of that tag will be injected into your page, and it may contain JavaScript as well, which will be executed. But in HTML, there are only a couple elements that will interpret links with the JavaScript schema. And one of them is obviously the href. Still, well, not vulnerable, like it's a feature, right? Sometimes you have to run some JavaScript when somebody clicks on a link. But there are other locations in HTML5 elements, like the form action can execute JavaScript. The poster tag, the poster attribute for the video tag used to be able to execute JavaScript. Not anymore, not in the latest versions, but it was vulnerable before. So and then also there are the HTML imports, right? When you can inject some JavaScript with the link tag in the header of the file. So how do we fix that? One, we can just strip out the JavaScript word in the string, but that's not a good option. It's better to use something like the URL parser, the URL library that will say, okay, the protocol is JavaScript, and you only filter. Well, is it better to search for the JavaScript protocol and disallow the JavaScript protocol, or is it better to search for the protocol that you're expecting, like HTTP, HTTPS, right? Whitelisting is obviously better, because it's not, as I said, not just JavaScript, but also the data protocol can be dangerous as well. And I don't know why this is not still a feature of the framework. So Germanico raging about it. It's like, come on. If untrusted input is coming into application and the schema starts with JavaScript, like, it already should be automatically taken care of, because that shouldn't be a feature. So let's look at a quick example here. All right. So, a little test application, and if we create post, and then instead of putting a URL, we just say JavaScript alert 1, create the link. Demo gods. I'm just going to go to some of the links that I already created. But basically, once you do that and you click on the link, and the script is going to be executed, right? So, yay, alert. Demo gods, right. Hopefully there'll be more interesting demos. All right. This is all easy and straightforward. What about cases where I need to have some HTML tags available for my users? If they're writing a blog post and they want to use, pink color to highlight something, right? Or bold or italics. So what do? We use markup. It's not early 2000s anymore. We have markup. Markup doesn't allow you to inject scripts. All good. Is that true? Well, the markup itself doesn't have anything for JavaScript, right? It only has the text editing features. But actually, if you do inject some JavaScript into whatever is then converted from markup to HTML, guess what? The libraries, like here, I have an example, right? So the user submits some markup, and then we use the showdown library to convert it from markup to the HTML and then display to the user. So when we display to the user, we convert it to HTML, we have to show the HTML. So how do we do this in React? Well, we have to use the dangerously set inner HTML. Like that's the only way we're gonna be able to show our pink font in the post. But if the user actually is able to submit script and it's stored in the database and then it is converted from markup into HTML, guess what happens with that script statement? It's not getting filtered out. The showdown library or any other markdown, well, the ones that I've seen, they are not the filtration libraries. They're not the sanitization libraries. They will take your JavaScript and put it into the output HTML, and you're going to stick it into the page. So if you're using markup, that doesn't mean you are, you cannot have a cross-site scripting. You still have to sanitize your code after the markup library did its, converted it to HTML. And one way, well, one of the best ways to sanitize your HTML is actually to use the DOM Purify library from Dr. Mario. It's amazing. Still has vulnerabilities every now and then, but they patch them pretty quickly. So here's an example, right? So here's my little React app that accepts some markup, right? So we have like, I can type today, the second title, but then if I inject something like image source X on error alert, right? So, yeah, come on, you guys don't have to clap for an alert pop-up. But yeah, so markup, be very careful about it. You still have to sanitize it. Another cool feature that React provides is server-side rendering, or DOM, server-side DOM rendering, right? How is it different from client-side DOM rendering? What is it? Why do we need that? Traditionally, in the client-side rendering, client-side rendering, we send the HTML from the server to the client. Then the browser loads all the JavaScript. Then loads React library, which is not small. Then it executes all the React bells and whistles. And that's when the page becomes visible and active, and the user can start clicking. So that third step of executing React actually takes some time, and it may take half a second, which is a lot of time. Nobody's going to wait for it, and if you're on a mobile device, that's take even a little bit longer. That's not going to work, right, for the users. So the server-side rendering concept is that, well, the rendering part is kind of performance intensive. And you don't want to do it on the client's browser, especially if it's a mobile browser and it's eating your battery. So it's much easier and faster to render it on the server side. So what the server-side rendering does, it takes the HTML, it renders it into what the page will actually look like, and then sends that rendered part into the browser. It becomes visible immediately. And then when the page is already visible, the browser downloads React and all the other scripts and then executes them, and then it becomes active. So it still takes that half a second, but for that half a second, the user can see the page. And while they're figuring out where should I click, by the time they click, the page is already active. So it's awesome, it's amazing. It's also great for search engine optimization, right? Because when you just send the final HTML with all the terms, titles, subtitles, great for SEO engines to grab. But what does it tell us in terms of security? So it kind of brings us to the old days, when you wrote like JSX, like not JSX, GSP, right? The server-side templates. You render a template on the server side, you execute everything, you make it look how the user should see, and only then you send it to the user. That means you're injecting data on the server side. And because the React is executing their things, doing its magic later in the game, whatever you inject when you're rendering your template is not going to be sanitized or processed by React. So if you're able to have an injection on that step 2, then React will not save you. Like all this contextually escaping magic is not going to happen. And when we render the page, we also have to send it some state, some data to fill it up. So, there are two steps, right? So we render the page, and then we set the initial state. And then the page becomes active on the client side. So how do we set the initial state? Well, we just set some JavaScript variable. All right, and usually it's called something like preloaded state. Application state is just global accessible variable on the window object. And we set it to JSON, all good, so that if the JSON contains some untrusted data, for example, contains the name that comes from the user, which you didn't sanitize because you're using React, you trust React, everything is good. Well, if I try to inject something and break out of this JSON context, if I inject a double quote to break out of my Ksenia name, JavaScript is just gonna escape it and put backslash in front of it, all good. But if I inject something like this, so technically, if we look at it from the JavaScript context, this is all a string, right? It's all in double quotes, script, alert, it's all string. Looks benign, we didn't break out of the JSON context. However, because it's a JSON context, but it also is an HTML context, when the browser parses the page, the HTML gets parsed first, and then the JavaScript interpreter kicks in, right? So when the browser parses the HTML, it finds this first script before the window, opening script, and then it finds the closing script and says, that's it, that's the script. So then the second script with the alert gets executed. It's an inline script. So this is your JavaScript injection, right? And the dangerous thing is that this code, this one, without any sanitization, is in almost every tutorial. Go to StackOverflow, how to do server-side rendering. That's the example that you're going to get. And it's going to be vulnerable. So if we'll look at another demo here. Okay, if I can. So if I submit my name, right, all good. If I submit the script here, alert pops up, all good. Well, not all good. But the interesting thing, if we look at the page source, the injection happens right here. This is before the React application starts its magic, right? The React is right here in the body. Like, this is where we load the bundle.js that contains the React library and does all the thing. And note that when I inject the name like inside the React code, it's all escaped. It's all good, right? It's less than, greater than, the React does its thing. But because you inject the data before the React, your state variable, like that's where the injection is happening. So how do I fix that? Oh, and the other thing is, that was a very simple example where the state is just in a JavaScript variable, no magic. But usually with React, developers are using Redux to maintain the state if your state is more than just a couple of attributes. Again, you go to the Redux documentation, the same vulnerable code was in their documentation until somebody found the vulnerability, filed a bug, and now what they suggest as a fix is actually just to do replace open bracket with less than character or whatever they're suggesting, the Unicode character. I mean, it works, I guess, but that's kind of blacklisting approach. So again, a better approach would be to use the serialize function from the serialized JavaScript library that what it'll do when it serializes JSON that you are submitting, it does JavaScript escaping. So all your less than, greater than special characters will be JavaScript escaped with the / Unicode character. And in this case, the browser will do the serialization for you, deserialization for you. So you don't need to do anything else on the client, on the client side. All right. The next vulnerability is the Eval. Again, like it's been so many years, and as long as the language has this Eval function, bad things are bound to happen. But it's so functional, and it gives you so many capabilities that JavaScript is never going to say, okay, we're not going to support Eval function anymore. Like there are so many frameworks that depend on that functionality. But the interesting thing is, so with the JavaScript deserialization, like this new vulnerability in the OWASP, and well, not just in the OWASP, but in our field, what happens is, for example, the serialized JavaScript library that I just said, it's a great library, use it. So they serialize the JavaScript, but do you think they have the deserialize function built into the library? Nope. So how do you deserialize things? What if you need to deserialize whatever you get that serialized data? So again, in their documentation, they say, well, just do this function, right? Deserialize eval and eval whatever serialized string you have. They didn't want to put this into their code because that would be a huge security issue. Instead, they just put it into their documentation and said, you developer, you write this function, you just copy paste it, and it's going to be in your code, and it's going to be your problem to fix it. It's not going to be our bug. Why? Because there is no function that's called safe eval. Like to solve this problem, you have to re-architecture your application. You cannot, it's not like concatenate SQL statement bad, use parameterized queries, easy fix, all done. Like there is no such fix for the eval. You just have to somehow think differently and do input validation or something like that. And then another example that I saw was, again, on StackOverflow. All of this is on GitHub example, on GitHub applications, like the examples that everybody is using in StackOverflow, where a developer wanted to have the React application send a JSX, that new template code into the client, and then update some element with this JSX code. And the developer was asking, well, how do I translate it into the JavaScript/HTML, and somebody recommended, well, just use the Babel library and transpile it, and then just do the eval on the output code. Like, yeah, right. Well, first, you don't use Babel on the client side, on the browser side, because it's big and heavy, and it's gonna use your processing power and the battery if you're using the mobile device. So, there's no solution to this, unfortunately, except for just it should be an architectural solution. All right, I'm almost out of time. I'm gonna breeze through the rest. The other thing with React is when you are fetching data from the server side, if you're using you will probably be using fetch function, the new JavaScript function. By default, it's using a GET request. So look for that as well. If you're actually sending some post data, don't send it with just the regular fetch. Use the post, set your credentials, and usually, by default, it doesn't submit any cookies. So you should either set the cookies to same origin if you are only doing it in the same origin space. If you are using cross-origin resource sharing, you have to set the cookies to include. Then they will be included on the cross-origin request as well. But by default, it's unauthenticated, right? No cookies, unauthenticated. React applications oftentimes use JWTs, which is a separate huge topic. There are issues with JWTs kind of by themselves. I'm not going to dive into that. But for that, you have to also include the authorization header, right? You're not using cookies, but you have to include the authorization header. Make sure your JWT is generated correctly. You're verifying them. You're signing them, blah, 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 all that stuff. So there's that. And yeah, conclusions and recommendations. So if you are reviewing React applications, things to look for is, definitely search for dangerously set inner HTML. Look for eval. Look for untrusted input in the URIs, in the hrefs, form action, all these HTML attributes that inject links, so URLs. And look if the components are created dynamically, and if any malicious input is sent, to those components. So those are kind of the key things that you can look for in React. And if you are using ESLint, the JavaScript linting tool, there are a couple rules for React. There's this library called ESLint plugin React. Most of the rules in that ESLint plugin are quality focused, but there are a couple of security rules that I highlighted here. So for example, it will help you find the dangerously set inner HTML. And you still need to do the data flow manually, right? This is just a linter tool. It's just a glorified grep, basically. And don'ts. If you're using SSR, server-side rendering, make sure you call the serialized JavaScript library before you stick it into your HTML, right? Look for that injection. If you're using fetch, make sure the calls are authenticated, have the cookies or headers, or and using the posts. And React also has type checking library that's called prop types. If you are using that, or you recommend developers to use that, then you have type checking without using TypeScript, but you will actually specify the types of your variables and attributes. And yeah, use ESLint plugin. Tell your developers to use it. That will be great. And that's it. Any questions?